What happens when two objects hit each other or collide? Well, according to the law of conservation of momentum, momentum is conserved between those two objects. The actual law states, in the absence of an external force, such as gravity or friction, the total momentum before the collision is equal to the total momentum after. In mathematical terms, we would say that the sum of the momentum before the collision has to be equal to the sum of the momentum after the collision happens. So remember that this means sum of. So we're going to be combining momentums. There are different types of collisions. There are 3 in total we're going to look at. And the first type is going to be a situation where objects do not stick together. The situation where objects do not stick or stick together is called elastic. You have 2 objects that come together. One object might be moving one way, the other way. They hit, and what happens afterwards is then they rebound and they split apart. In this case, you can see that you start with 2 objects and you end with 2 objects. You have 2 objects before and after the collision. The elastic collision equation starts with the momentum of each object. So you're going to have the momentum of object 1 initially, at the beginning. Okay? We add that to the momentum of object 2 initially, or at the beginning. That is going to then equal the momentum of object 1, the final momentum after the collision, plus the momentum of object 2, the final momentum after the collision. So this side is all before the collision, and this side is all after the collision. Now typically momentum is hard to calculate because we need to know the mass and the volume. So what we can do is we can substitute mass and volume in for this equation. So if I do that, we know that P is equal to M times V. So for momentum number 1, here I can substitute in the mass of object 1 times the velocity of object 1. Okay? I can add that to the mass of object 2 times the velocity of object 2. Okay? And then I can do the final momentum for object 1, which would then be the mass of object 1 times the velocity of object 1, the final velocity, plus the mass of object 2 times the velocity of object 2, its final velocity. So this is actually the equation that's a lot easier to use because it's much easier to find the variables. The second type of collision is a situation where objects will stick together. In this situation, you will have 2 objects before the collision and 1 object after. A situation could be something like 2 freight cars, okay, on a train that end up colliding into one another. So this one's moving this way, this one's moving this way. They hit each other And what happens now is you have one really big object that now continues moving in one direction or the other, or perhaps stops. But we start with two objects and end up with one bigger object here. The equation for an inelastic collision is very similar to the one for an elastic. You will have the momentum of object 1 plus the momentum of object 2, and that has to equal the total momentum after the collision happens. So again, remember, this is before collision, this is after. If we wanted to simplify this or break this down even more and get more detailed, we can substitute just like we did the other one. So we have the momentum of object 1, which we know will be the mass times the initial velocity of object 1, plus the mass of object 2 times the initial velocity of object 2. And now, because the two objects have locked together, we have to take our two masses and they're going to be combined. So the way we write this, or we represent this, is we say the mass of object 1 plus the mass of object 2. Now, because they're all together, we don't have two velocities anymore, we only have one velocity. So this would just be the final velocity over here. So we have that mass of object 1 times the velocity of object 1 plus mass of object 2 times the initial velocity of object 2. They combine together and we only have one velocity after an inelastic collision occurs. The last type of collision is called the explosion type. Sometimes the explosion type is called the backwards inelastic because it's the flip of the inelastic equation. You will end up starting with one object before the explosion and you will have two afterwards. And one of the most common things we could have is a rifle. So if we have, I don't know, okay, and a bullet that's inside. Before the collision or the explosion happens, okay, afterwards we will end up with the rifle and the bullet. I know my bullet's changed size, but you can see that there is one object before and then we have two objects after. The explosion equation is actually the exact flip of the inelastic. So we start with the total momentum of the system of that first object, which will then be equal to the momentum, the final momentum of object 1 plus the final momentum of object 2. If we want to simplify this out, again, we can take these variables and make them more detailed. So for the total momentum, we would need the mass of both objects combined times the velocity, okay, the initial velocity here, and that's going to give us the mass times the velocity of object 1, the final velocity of object 1, plus the mass of object 2 times the final velocity of object 2. Each piece, again, is a separate momentum. That's all, everyone. Have a great day.